Greetings everyone and welcome to Mr. Musselman's online classroom. Today we're going to be talking about the steps that you need to follow to create professional looking scientific graphs for your lab activities or lab reports. We're going to follow these 5 simple steps that you see on your screen. We're going to start by labeling our X and Y axes, then setting axes intervals, plotting our data points, creating a key or legend that goes with those data points, and then titling our graph. To illustrate how to do this, we're going to use some data from a recent lab that we performed in class. The table seen here represents the temperature of 2 different samples, in this case water and sand, and how they've changed over 20 minutes of time as a result of being heated by a heat lamp a set distance away. We're going to show this change in temperature by charting those points of both the water and the sand temperatures on a graph. We'll start with step 1, labeling our X and Y axes. When I go to begin starting to chart my data, I want to take into consideration the size of the paper or the space that I'm using and where this graph's going to be. So I'm going to start my Y axis right about here, leaving some space on the left side of it for some labeling and some numbers. And you notice I'm also being a little bit deliberate about my straight edge here. I am making it perfectly straight, right? And I'm actually counting some boxes, and I've counted 10 boxes, and I'll talk about why I've done that later on. Right? And then I'm going to also come across here, and I'm going to count off 12 boxes here. And again, we'll talk about why we do that later on. So now I've got 2 nice straight X and Y axes, and again I gotta start by labeling these axes. So the first one that I've got, my X axis, this is where I'm going to chart the time of my the heating of my substances. So I'm going to write time here, and I'm also going to include the minutes, the units of which my samples, or excuse me, I'm recording my time. Right? It's important to include units when you are graphing so people understand the sort of scale in which you're collecting your data. Minutes could be much different from hours, could be much different from days. I'm also going to do this for my y-axis. My y-axis is going to be my temperature, and when we measure temperature scientifically, we of course use Celsius, not Fahrenheit. Okay, so I have my labels made for each axis. So I can check that off the list now. My second step is to set some axis intervals. Now I cheated a bit here initially because I was thinking ahead about how much I need my intervals to be. When I look at my data table, I notice that for the time, we're going to go a span of 20 minutes. And for temperature, our temperatures range between 20 and 30 degrees Celsius, which is a 10-degree difference. Now, if you remember, on my graph, I counted 10 squares up the y-axis, which is where our Celsius, our temperature, is marked. I'm going to now mark in intervals here, starting at the bottom. And I'm going to start with 20, and then every 2, I'm going to make an additional mark that I will later label with a specific interval. Can you guess what my interval is going to be on each of these little tick marks? If you guessed 2, starting with 20, we're in pretty good shape. Got a good sense for numbers here. Again, we're going to want to make those a little bigger. So I'm going to go ahead and label the rest of these right now. Notice that I've lined up each of my tick marks with the number. The number is not put in between. This is to show precisely to the graph reader where the intervals lie, 20, 22, 24, and so forth, along the grid lines. Placing them somewhere in the middle can be a little bit ambiguous and leave it up to the imagination of the graph reader, which can lead to some incorrect interpretation of data. I'm now going to proceed with labeling the intervals of my x-axis. Now, as you may remember at the beginning, I counted off 12 small graph blocks for my x-axis. I will, of course, start my x-axis with my first time number, in which case 0, and I'm going to end my line with the last time recorded, which was 20. While I label these numbers, can you quickly think about what you would use for a time interval here and how many spaces in between each time interval there would be? Do you have your prediction? If you were thinking that I would be placing time intervals every 3 blocks at a rate of 5 minutes each, you guessed correctly. This is obviously a good decision for this graph because those tick marks will line up with the grid lines of the graph paper, and people are pretty familiar with counting by fives. So we can now check off that we've completed our axis intervals. Our next step is to plot our data points. When we look at the table, we notice that we actually have 2 lines that we need to plot. So we're going to have to distinguish between these two pretty carefully. Let's start with the water. Notice that we start at 20 degrees Celsius, then for 5 and 10 minutes we go up 1 degree Celsius, and then for the remaining 5 minutes we go up 1 degree Celsius each, for a total of 23 degrees Celsius at 20 minutes. So I'm going to chart that right now. I'm going to do so by using these kind of silly stamps up here. I'm actually going to use a star point for each data point that I recorded for water temperature. So if you remember, at 0 minutes, the temperature of our water was 20 degrees Celsius. At 5 minutes, the temperature of the water had gone up 1 degree Celsius to 21. At 10 minutes, our recording stayed the same and was at 21 degrees Celsius. And then for 15 minutes, we had 22 degrees Celsius, and 20 minutes, we had 23 degrees Celsius. Notice how each time I placed a data point, I followed the grid line up from the x-axis and lined it up with whatever degree I had to mark on the y-axis. You can do this at home by either using 2 rulers or a transparent ruler or some other sort of straight edge. Doesn't need to be a ruler. But that will help you make sure that you make accurate data points on your graph. Now for the sand temperature, it's a little different. The temperatures jump up as follows: 20 degrees for 0 minutes, 22 degrees for 5 minutes, 25 degrees for 10 minutes, 28 degrees for 15 minutes, and then 30 degrees for 20 minutes. So when I go to mark these, I'm going to use something a little different. I'm going to use these happy faces instead. And just like the first one, our starting temperature is 20 degrees Celsius. But our second temperature at 5 minutes is 22 degrees Celsius. So that's going to be a little higher than that star. And then at 10 minutes, we had a big jump to 25 degrees Celsius. For 15 minutes, I jumped to 28 degrees Celsius. And then for our final recording at 20 minutes, we had 30 degrees Celsius. So clearly, when we look at these two different types of plot lines, there is a significant difference in the temperature, as we can see in sort of the slope that is beginning to form from these data points. So we've effectively plotted our data points. Now, something that scientists often do is they either connect these points directly, or they add in something called a best fit line. A best fit line tries to take into account some of the error that might coexist when you are taking recordings. And what they try to do is they sort of average in all of your recordings and create a consistent slope for all of them. So for example, when I look at the sand marks, the sand temperatures readings, I'm going to make a line that generally follows all of them and shows a consistent rise in temperature, but as you can see, some of the points are a little bit off the mark. They kind of miss a little bit above and a little below. But when we add in this line, we can say that our temperature change for the sand was pretty constant. And aside from a few variations that could have come from the way we were recording or some flaws in our data, right, this best fit line shows a pretty consistent rate of change for our temperatures of the sand sample. We can create another best fit line for our water samples as well. As you can see here, the slope of this line is a little more gentle than the slope of the water line, or excuse me, the sand line. And that's because the temperature changed at a much slower rate than the sand did. Here, once again, we're going to try to get a best fit line. We're going to try to fit them closest to all those points. Now that we have our best fit lines placed in, we're going to wrap up creating the scientific graph. We're going to start by making that key, or what others call a legend. If you remember, we used some different types of points for our sand and water. For the sand, we used the smiley faces, and for the water, we used the star points. So in my key down here, I'm going to just label each of those data points what they represent. In this case, the sand is represented by the smiley faces. And the star points, of course, mark the water temperatures. We've got one more thing on the list, titling our graph. This can be the easiest part of making a graph if you're thoughtful about it. Because generally when we label scientific graphs, we simply are telling our reader exactly what it is that they're looking at. In this case, it's pretty clear. We're looking at the change in sample temperature over time. Typically, we place the titles of graphs at the top, but sometimes you can put them at the bottom as well. In the end, you want them to be large and prominent so that they're clear that they're the titles to your readers, and kind of draw attention to themselves so people know what they're looking at. All right, I'd say we have a pretty decent graph. So now it's time to make your own. Good luck!